So today's assignment, we're going to be solving quadratics by using a process called completing the square. But let's go ahead and get started with these simple questions first. So I'm going to call these, first of all, level 1 questions. We're going to get up to a level 4 today, so we'll see how we do. So I'm going to start doing the first one for you, then I'm going to have you pause the video and see if you can do 2 and 3 on your own. So I'm going to start, because it's x minus 4 in parentheses, I'm going to start by getting rid of the squared here first. And so I'm going to take the square root of this and the square root of both sides. And so, excuse me, and so I will have x minus 4 here because the square and the square root undo each other. And that's going to equal the square root of 36, which is plus 6. I'm going to write it or negative 6. And then when I add 4 to both sides, I'll add the 4 to the positive 6, and I'll add the 4 to the negative 6. And so x will equal 6 plus 4, which is 10, or negative 6 plus 4 is negative 2. And I can plug both of those in to make sure that they work. If I plug a 10 in, 10 minus 4 is 6, 6 squared is 36. If I plug a negative 2 in, negative 2 minus 4 is negative 6, and negative 6 in parentheses squared is also 36. So both of those equations work. So I'm going to have you pause the video and then do number 2 and 3 and restart the video and see if you're able to figure those out. So here's what you should have done for number 2. Take the square root of both sides, and we're going to have x plus 7 equals 3 or negative 3. And then I'm going to subtract 7 from both sides, and so I'll have x equals 3 minus 7 is negative 4, or negative 3 minus 7 is negative 10. And for number 3, again, I'm going to take the square root of both sides. So I will have x minus 1 equals positive 5 or negative 5. And so then I'm going to add 1 to both sides. So I will get x equals 6 or negative 4. So that's how we're going to be ending the process of completing the square. Here's the only situation with this, though. We are going to not start every equation like this. For example, number 1 isn't going to start off looking like this. It's actually going to start off looking like this. It's going to be x squared minus 8x plus 16 equals 36. And you're going to have to write it like that. Can you figure out how? There is a pattern there. Number 2 would not start off looking like this. Number 2 would start off looking like this. It'd be x squared plus 14x plus 49 equals 9. And you would end up writing it like this. I'm not going to tell you how to do that. You're going to have to figure that out on your own. Number 3 would look like this. It would be x squared minus 2x plus 1 equals 25. So if we go back to number 1, here's why I know these two expressions are the same. If I took x minus 4 and I squared it, I would get x minus 4 times x minus 4. Well, if I FOIL this, it's going to be x squared minus 4x minus another 4x and then plus 16. And so we would write that as x squared minus 8x plus 16. That's what we have up here. But can you figure out how to go in the other direction? How do I start with something like this and write it as x minus 4 squared? Key here is negative 8 and negative 4. That's the same pattern as positive 14 and positive 7. Negative 2, negative 1. You see, this number here is always half of this linear coefficient. 7 is half of 14. Negative 4 is half of negative 8. And then how do we get the 16? Well, it's 4 squared. 49 is 7 squared. Positive 1 is negative 1 squared. So once you figure out those patterns, let's take a look at these next 3 questions. These next 3 questions are kind of like they're written in blue, and then you'd have to solve them just like we did in red on numbers 1, 2, and 3. First, we want to figure out how could I rewrite this expression, and I'm going to rewrite this expression as x minus 3 squared equals 81. This looks like now exactly like in 1, 2, and 3. Trick is half of 6 is 3. 3 squared, 9. And so this is a perfect square trinomial, and if it's a perfect square trinomial, we can write it as x as this binomial squared. In this case, it's x minus 3 squared. Number 5, I would write the same way. It's going to look like this. It's going to be x plus 5 squared equals 18. Half of 10 is 5. 5 squared is 25. Number 6 is going to look like this. It's going to be x minus 4 squared. Half of 16 is negative 4. Negative 4 squared, this should be x minus 8 squared. Half of negative 16 is negative 8, and negative 8 squared is 64, equals negative 200. Once you're able to write it like that, then solving it is just as easy as what we did in 1, 2, and 3. Let's go back to number 4. I would take the square root of both sides. This is going to be x minus 3 equals 9 or negative 9. Add 3 to both sides, to the 9 and the negative 9. We're going to get x equals 12, or this is negative 9, negative 6. Do the same thing here. I would take the square root of both sides, and I would have x plus 5 on the left equals the plus or minus the square root of 18. Well, square root of 18 is like the square root of 9 times the square root of 2. So that's going to be, I'll just write it like this. 3, I'm going to cross this off, 3 times the square root of 2, and negative 3 times the square root of 2. So then when I subtract 5 from both sides, I will have x equals 3 radical 2 minus 5. And then here I would have negative 3 radical 2 minus 5. Although I would probably write it like this. X equals negative 5 plus 3 radical 2 and negative 5 minus 3 radical 2. Then if I do the same thing for number 16, I'm going to take the square root of both sides. And so this is going to be x minus 8 equals the square root of negative 200. Well, that's like the square root of negative 1, the square root of 100, and the square root of 2. That's going to be 10i radical 2, or negative 10i radical 2. So then when I add 8 to everything, I'm going to have two solutions. One of them is going to be 8 plus 10i radical 2. The other one is going to be 8 minus 10i radical 2. That's really sloppy, but you get the idea. Those are my two solutions. Let's move on. That's level 2 type of questions. Let's take a look at a question like number 7. So you might start off trying to figure out, well, how am I going to rewrite this equation? You might want to think, well, first I would just make this 4. But there's a problem, because if I make this as x plus 4 squared, that number should be 16, and it's not. It's 25. So we're going to need to get rid of that. I'm going to not going to be able to write it like that right now. This is not a perfect square trinomial. So to get it to be a perfect square trinomial, I need to make it one. And the problem right now is this 25. So I'm just going to get rid of it. I'm going to subtract 25 from both sides. And now I'll write it as x squared plus 8x. 25 minus 25 is nothing. 58 minus 25 is 33. And so now I want to put, and I'm going to leave a space here because I'm going to put something in this space that makes the left side a perfect square trinomial. I want to write it as x plus 4 squared. But if this is a 4 here, this has got to be 16. And so I'm going to add 16 to both sides of my equation. And so this now can be written as x plus 4 squared equals 33 plus 16. Well, that's going to be 49. And now I can go ahead and take the square root just like I did in 1, 2, and 3. This is going to be x plus 4 equals 7 or negative 7. Subtract 4 from both sides, and we're going to get x equals 3 or negative 11. Let's take a look at number 8. Again, not a perfect square trinomial. Half of 6 is 3, but 3 squared isn't 18, so I'm going to get rid of the 18. I'm just going to move it to the other side. I'm going to write it like this. X squared plus 6x. I'm going to leave a space here. And that's going to equal 84 minus 18. Well, that's 66. And I'm going to leave a space here, because whatever I add here, I'm going to add here as well. So I want to write this as x plus 3 squared. But if this is a 3, this has got to be a 9. So I'm going to add 9 to the left, and I'm going to add 9 to the right. And 66 plus 9 is 75. So now when I take the square root of both sides, I'll have x plus 3 equals plus or minus the square root of 75. Well, the square root of 75 is like 25 times 3. So the square root of 25 is just 5. So it's 5 radical 3 or negative 5 radical 3. So then when I subtract 3 from everything, I'll have x equals negative 3 plus 5 radical 3 or negative 3 minus 5 radical 3. And those are my two solutions. If we move on and take a look at number 9, again, it's not a perfect square trinomial. I'm going to get rid of the 7. I'm going to subtract 7 from both sides. So I'm going to have x squared plus 5x. I'm going to leave a space here. And that equals 15 minus 7 is 8. And I'm going to leave a space here. Well, I want to write this as x plus half of 5 is 5 halves squared. Well, if this is 5 halves, I'm going to want to square 5 halves to put it here. Well, if I square 5 halves, that's going to be 25 fourths. And so I'm going to add 25 fourths to both sides. Well, 8 over 1 plus 25 over 4, I'm going to get a common denominator of 4, which means 8 times 4, that's 32 over 4. And 25 plus 32 is 57 over 4. Well, then I'm going to take the square root of both sides. Ugly numbers, but the process is still the same. I'll have x plus 5 halves equals plus or minus the square root of 54 over 4. Well, or 57 over 4. Well, that's going to be the square root of 57 over 2, or negative square root of 57 over 2. So then I'm going to just subtract 5 halves from both sides. And I'm going to subtract it from both of my numbers on the right. So I will have x equals negative 5 plus the square root of 57 over 2, or I will have negative 5 minus the square root of 57 over 2. And those are my two answers. They look ugly, but they're the correct answers. Let's move on and take a look at this last level 4 question. And I typed this in wrong. This should not be a 3 here. It should just be 3. So the problem here is this. I'm going to have 2x squared. Okay, so I lied. I want this to be 30. So I'm going to solve this equation, but in order to solve this, I need to get the x squared by itself. So if you ever have a coefficient out here in front of the x squared, you're going to have to divide everything by that number first. So I'm going to divide everything here by 2 first, because I need it to be just x squared. So it's going to be x squared plus 7x plus 15 equals 8. Then I want to complete the square, so I'm going to get rid of the 15. I'm going to subtract 15 from both sides. So it's going to be x squared plus 7x. I'm going to leave a space, equals 8 minus 15, which is negative 7, and leave a space. Then I want to write this as x plus 7 halves squared, but in order to be a 7 halves here, this is going to have to be 7 halves squared, which is 49 fourths. So I'm going to add 49 fourths to both sides. This is negative 7 over 1, but if I change it so the denominator is 4, it's going to be negative 28 over 4. And positive 49 minus 28 is 21 over 4. And then when I take the square root of both sides, it'll be x plus 7 halves equals the square root of 21 over 2 and negative square root of 21 over 2. So when I subtract 7 over 2 from both sides, I will have x equals negative 7 plus the square root of 21 over 2 and negative 7 minus the square root of 21 over 2. I did that really quick because I wanted to make sure I fit it into this video, but hopefully that made sense. The key here is you have to get the coefficient of x squared to be 0 before you can begin. Good luck on your homework assignment, or to be 1 before you can begin. Good luck on your homework assignment.